this talk series is my labor of love. And by that I mean that I convinced Curtis to cut the check so I got to hear brilliant speakers talk and you guys just all get along for free. A few brief announcements. First of all, Travis would kill me if I didn't mention the fact that Uber is hiring. We are hiring at all phases of the company. Designers, data scientists, you get to work with me, engineers, PMs. I imagine if you even want a receptionist, we got a few jobs as well. So if you're interested, come find me or any of the employees during, before, or after any of these talks that we're doing, and we'd love to point you in the right direction. Secondly, as you've noticed, for those of you who've been to the last few, every month the tables are getting closer and closer to the middle. In fact, we have a rail in the midst of my seating area. So next month, we are going to be doing another Uber Tech Talk. I don't have a date yet because we're going to be moving them off-site. We are currently talking with a few co-sponsorship deals, but we are going to have another talk roughly this time next month, somewhere in the cool SF SOMA startup area. So keep your eyes peeled. And again, thank you all for coming. It has been horrible weather, so I appreciate it doubly. Without further ado, we have Josh Wills, Senior Director of Data Scientists. I shortchanged you on the invite.
It's quite a title.
Yeah. I'll let him take it from here.
Thank you. Thank you, Kevin. Thanks very much. I love tech talks where there's beer. You know what I mean? It's just the best ever. Although how am I going to hold the microphone and the beer and move my slides forward? I didn't really think this through at all. Kevin can hold the beer for me? No, Kevin, don't hold the beer for me. It'll be fine. Let's see. Hi everybody. So I'm Josh Wills. Oh, I'm being recorded? That's crazy cool. Okay. Are you gonna like post this somewhere, or what's the just whatever
My YouTube.
for your own use or
YouTube.
for private use of our audience, or what's the intended? I don't know. I don't mind you recording me. I'll just be less offensive than I normally am. Guys, thanks a lot for having me here. I really appreciate it. I'm a huge fan of Uber. I don't know if any of you, I was thinking about actually like going through my email and like plotting my like weekly, monthly, et cetera, spend on Uber over the past year. Mm-hmm. But it's like, that's not gonna make me happy, right? There's no upside to that. All right, Uber employees don't find that funny. That's fine, okay. The original title of this talk was How to Choose a Machine Learning Algorithm, a Machine Learning Approach. I don't know if you guys actually read like the substance of the abstract for the talk or whatever, but I was trying to kind of make it obvious that I don't really know anything about machine learning, and that was sort of a joke. I'm a data scientist, not a machine learning expert. So we'll talk a little bit about machine learning today, but it'll be from my perspective as a data scientist and not, you know, someone who actually like knows stuff about machine learning, right? That kind of thing. I mean, I know how to like use machine learning to make money. That's something, right? That's kind of cool. Okay, right, that's fine. A little bit about me. Have any of you seen me talk before, by the way? Has anyone seen me? You have? Or, okay, so not enough of you for me not to make the same jokes over and over again, so sorry about that, guys. So my name is Josh Wills. I am Senior Director of Data Science at Cloudera. If you don't know Cloudera, we are like a Red Hat for Hadoop. If you don't know what Hadoop is, this is going to be a very long hour for you. I apologize for that in advance. So I've been at Cloudera for almost 2 years. Almost got wooed over to Uber a couple of times during that time period. A few months where my debt to them sort of got to the level where they were like, listen, you have to come work for us. You can't pay us money. So I've been at Cloudera for about 2 years. Before that I was at Google. My first job at Google was working on the ad auction. Like you do a search on Google and ads show up, like 2008, 2009, that was me. You're welcome. Oh, come on now, booing me. That's terrible. And not as bad as not thanking me, but nonetheless. After that, I did a whole bunch of data infrastructure stuff. So logging things, A/B testing, multivariate testing, recommendation systems, machine learning systems. I've done basically everything you can do with data over the past 5 or 6 years or so. Okay. All that is really great, and that's sort of why I'm like worth listening to. But if I was to die tomorrow, what I will be most remembered for is this tweet I did about a year ago, about May or so, which is a sort of proper defensible definition of a data scientist. Data scientist is someone who is better at statistics than any software engineer and better at software engineering than any statistician. It's fun to read, it's fun to say, right? And it works pretty well in about 140 characters or so. So if your mom asks, what does you do all day, just tell her that, and she'll think how clever you are.
You also have bad at the end there, but worse at either than both.
But worse at either than both, right? So that's actually a great question. Yes, right.
What is it?
Sort of Brad Wojtek's sitting right here, right? You guys, everyone know Brad? Right? He's a troublemaker. People know Brad? Brad was like Uber's first data scientist, right? And he tried to recruit me to come work here, but did a really bad job of it. And so that's why, if Travis is here, that's why I don't work here. It's because Brad did a bad job. Trying to be helpful. And so Brad made the comment that a data scientist is someone who is also worse at software engineering than any software engineer and worse at statistics than any statistician. And you know, I'm a little biased on that one. I think I'm actually a better software engineer than a lot of software engineers, and I think I'm a better statistician than a lot of statisticians. I do. So I don't define things that way. That might be sort of hubris on my part, right? You know, like easily. You guys, actually, in part of this talk, you will all have the opportunity to look at code I've written, and you can decide whether or not I'm worse than the average software engineer. But yeah, that's why I don't necessarily define it that way. I think what's nice is that I know software engineers who are vastly better at software engineering than I am, and I know statisticians who are vastly better at than I am. And what I like about being a data scientist is being able to understand their language and like know what they're talking about and be able to learn from them. Right? Does that make sense? Yeah. Okay. All right. Moving on to more silly things. What do data scientists do? How exactly do we spend our time when we're not giving talks? There was this meme on Facebook, I think it was like 2 years ago or so. This talk is basically just full of memes, honestly, the whole way through. This meme was about like what it was, like how people describe their jobs or how they thought about what they did. And so I adapted it for purposes of this talk, and I said, the first thing is, what do I think I do? I think of myself as a mathematician. I was a math major in college, and I kind of like most math majors never really got over it. You know what I mean? Nodding around the other math majors like, yes, I also never really got over it. I'm hoping against hope that someday that algebraic topology would come in handy. But I think I'm a mathematician. I think of myself as working on systems of equations, designing models, right? This is like, you know, staring at blackboards while I mop floors, that kind of thing. That's like how I really think of myself. Like I'm a mathematician, right? Other people though, like what does my mom think I do? What does I do? This is Minority Report. This is Tom Cruise Minority Report. If you've seen this movie, it's Tom Cruise, and he's got this cool screen where he can visualize all this crazy information, right? It's like moving stuff around and all that. It's like, you know, right? And I think, you know, in sort of the popular culture or popular consciousness, what data scientists are famous for is visualizations, like really cool visualizations, right? So people assume that what we do all day is just sit around visualizing things on our cool monitors, moving stuff around, right? If wishing made it so. Anyway. Of course, there's what I actually do. What I actually do is clean data. A few painful laughs from the audience of people who do this for a living. What I actually do is clean. I am Forrest Gump, and I have a toothbrush, and there's a big floor full of data, and I clean it. And that's what I do, right? Because honestly, cleaning data is my highest ROI activity. Cleaning data is the most useful thing I can do with my time, right? Because if I have a cleaner, better, richer, more interesting data set, then my machine learning models get better, my dashboards get more accurate, my experiments like come to, you know, statistically valid conclusions faster, right? Cleaning data is the best thing I can be doing with my time. Again, obviously when I'm not talking places, that kind of thing, all right? So I'm a data cleanser. Okay, a little bit about what data scientists do. A radically condensed overview of industrial machine learning. Does anyone find that funny? I was curious if anyone would get that joke. No? Okay, it's all right. Good to know. But nonetheless, it's a joke, but it'll be, you can Google it later, it's fine. But it'll still be true. Radically condensed overview of industrial machine learning. So, let's talk about goals, let's talk about objectives. What exactly are we trying to do with machine learning in industry? And sort of the place to start is sort of where machine learning originated, which is in academia. This is the Alhambra in Granada, Spain. Absolutely beautiful if you've ever been there. It was also the site in 2011 of a conference called NIPS, Neural Information Processing Systems. It's a very sort of famous, popular, important machine learning conference in academia. By the way, if you guys are ever like find yourself in the position where you're giving a talk and you're like trying to find a good image for NIPS, just be really careful with your Google searches. You know what I'm saying? Just like that's it. Not related to anything else. So NIPS is a very prestigious conference, and if you are an academic machine learning researcher, getting a talk accepted, getting a paper accepted at NIPS is a really big deal, okay? So all of your goals and all of your objectives as an academic machine learning researcher are really focused on the sort of the things you can do that will get your paper accepted at NIPS. And what that typically means is coming up with some new algorithm that's never been seen before, that is faster, in some sense, faster than the existing machine learning algorithm, or better in some sort of predictive measure than any existing machine learning algorithm. And the way you validate that is you apply it to some data set that people have analyzed hundreds and hundreds and thousands of times, and you show, oh, look, here's my algorithm. It's new, it's clever, it's better along these dimensions, right? And you get published in the conference proceedings, and you get a tenured chair, and all kinds of great things happen to you, all right? And that makes you really happy. That's what you want as an academic machine learning researcher. Now, let's sort of like focus on our objectives. In industry, we have slightly different objectives. I don't know about you guys, this is my objective. Got this sort of picture of this up on my wall. This is going to be my yacht that's also an island. Cloudera is going to hit big, and I'm going to go build this thing and sail around the world. It's going to be fantastic. Our objective is to make money. We're trying to make money, right? And the way that you make money is sort of very, very different from the way that you get published in the proceedings of a very prestigious conference, okay? Different sort of goals here. We also work on, I actually like to think of the sort of industrial machine learning problem as an impossible problem. I worked on advertising at advertising at Google. This is why you don't drink beer before the talk. Advertising at Google, and there's sort of like, at Google is a very kind of like culture of, sort of like competition or snootiness, you know what I mean, between ads and search. And like apps too, but no one cares about them. But like ads and search, right? Sort of like Texas and OU, or Duke and UNC, or Cal and Stanford, like that kind of thing. There's a competition, right? And so I worked on the ad side, and so my perspective was always that search was an easy problem. All you had to do in search was basically make the user happy within the kind of financial resources and constraints of Google's technology infrastructure, right? Person types in a query, find them what they want. That's it. That's your problem, right? Advertising, very different. Advertising is a three-body problem at best. In advertising, you have to make Google money, you have to provide good ROI for your advertisers, and you have to either make users happy or at the very least not piss them off, right? This is a much, much, much harder problem. And therefore, to work on ads, you had to be much, much, much smarter than you did to work on search, right? That said, there's a lot to be said for impossible problems. The great thing about working on impossible problems, very low expectations, right? It's impossible. If you can do anything, that's amazing, right? This is, okay, maybe not everyone feels this way. I thought that was really cool, right? It was fantastic. And a lot of these industrial machine learning problems are in fact impossible. It is, for instance, impossible, provably impossible, to separate the effects of UI from the quality of an ad when you're doing machine learning to like predict click-through rates, right? There's no way for you to separate where is the ad position, what is the color, all that kind of stuff. There's no good way to separate that from what is the content of the ad, how relevant is it to the query, all that kind of stuff. Can't be done. Impossible problem, right? But Google has to solve it, and so does Facebook, and so does Twitter, and so does everybody else. Bless you. Yeah, impossible problems are fantastic. Impossible problems are great, great, great to work on, all right? So we have these impossible problems, but what we do in industrial machine learning is we optimize what we can. And the one thing we know we can optimize is speed. The one thing we know we can optimize is we can do things faster, and things will be better if we do things faster. This hangs up around, I stole this from Facebook's data science team. They have these posters all over their offices. This is from New York. Done is better than perfect. Yes, exactly. Done is so much better than perfect. So much better than perfect. If you get an academic machine learning, this is just going to be a long talk, academic machine learning researcher, and you dump them in an industrial setting, they are going to want to come up with like the perfect model. Right? Just beautiful, elegant, pure, pristine, gorgeous model that really captures every nuance and every essence of the system, right? That's not me. I want the thing that I can deploy yesterday, right? And why do I do that? Because the thing that I can deploy yesterday will be a little bit better than whatever my competitor is doing right now. And if it's a little bit better than what my competitor is doing, a few more people will use it. And if a few more people use it, I'm going to get more data than he's going to get, right? And if I get a little bit more data, my model's going to get a little bit better. There was a sort of debate in data science, machine learning, I think it was maybe about a year ago or so. People were talking about people versus data versus algorithms, What's the most important thing? People versus data versus algorithms.